In this video, we're going to introduce the idea of mean, median, and mode. If you read enough newspaper articles or articles on the internet, every one of these will be called an average at some point. So let's try to figure out what they mean. They all have something to do with the center of the data. So let's define these carefully. In this case, Chifaru is going to look at a simplified version of her data about how much Orange Crush her friends wanted. So we're going to look at 12 data points, the first 12 that pop up. And she wants to know something about what does an average amount of soda mean at this party. The most common definition of average is the mean of the data. So the mean of the data is we add up, we take the sum of the data points, and then we divide by the total number of data points. So we're going to add up our 12 data points, and since we have 12, we're going to divide by 12. Some notational things. If we have data for our entire population, all of the individuals that we're interested in, we use the special Greek letter mu as our mean, and instead of n as our number, we use a capital N. I'm not so worried about the capital N, but the Greek letter mu for our population mean, we really want to use that because that is very common. If we only have data for a sample, which in this case we do, we only took 12 of the data points. So we're going to use x bar as our mean, right? So x bar in our case is going to be our sample mean for our 12 data points. Okay, so take a minute, go back to our data set, add up the data and divide by the number of data points to calculate Chifaru's sample mean. So what I got is the sum of the data points was 5,810. I had my 12 data points, so the mean amount of soda in this sample was 484.2 milliliters. This is rounded. Right. So what did we just calculate? Well, if everyone at the party drinks the same exact amount of soda, but they drank all of the soda that we calculated, this is how much each person would drink, right? We take all the soda for these 12 people, pour it into a bucket, and distribute it evenly among the people. This is how much soda that there is. The next thing that we can do to figure out what an average soda drinker looks like is called finding the median. Right? The median is the point is the number that separates our data points into a higher half and a lower half. So how do we calculate this? First, we take our entire data set and we order the data from low to high. For the data set for Chifaru's sample, it's going to look as follows. Okay. The lowest data point in the sample is 180. The highest is 1,800. Right? To find the middle, we try to find the number that separates this into two sets of the same size. So since we have 12 data points, the chopping point is going to be halfway between the 6th and the 7th data point. So there's going to be 6 data points over here and 6 data points over here. This middle point here is going to be our median. Now there's a number of ways to do this. The most straightforward is if our median is not a data point, if it's halfway between two, well, we just take the average of those two data points. So the average between 360 and 375, the midpoint there, 360 plus 375 or 2, is 367.5 milliliters. That is the median of this data set. There are some quirks about even data sets and odd data sets. Once the data set gets large enough, this doesn't matter very much to us. But If we have an odd number of data points, the median is the data value that is the center of this set. Right? In this case, we have 5 data points. To cut it in half, we need 2 data points on this side and 2 data points on this side, and our median is the one in the middle here. So for an odd data set, the median is going to be one of the data values, the 7 in the middle. If we have an even number of data points, our median, the thing that chops it into 2 even sides, is not going to be guaranteed to be a data value. It's certainly not going to be a data point. So halfway between 7 and 9 is going to be our median in this case. So it's going to be the average of 7 and 9. So the median in this case is going to be 8. That's the point that chops this into 2 evenly sized sets. There is something distinctly different about these 2 statistics, the median and the mean. It turns out that one of them is very much affected by extreme values, and one of them is not. If a statistic is not affected by extreme values, we call it resistant. In this case, the median happens to be resistant and the mean is not. So let's take a look at 2 distinctly different data sets and figure out what's happening here. In this case, I have the data set 4, 5, 6, 9, 10. There's 5 data points. They're ordered from low to high, so our median is going to be 6. The mean, we would add these things up and divide by 5. So for this data set, 4, 5, 6, 9, 10, the median is 6, and the mean is 6.8. But let's look at a data set where we replace the high value with one that's very extreme and see which one of these 2 statistics changes more. Let's consider the similar data set, 4, 5, 6, 9, and 77. Okay? Here, again, this is ordered low to high. The median of this set is still going to be 6 because there's 2 data points to the right and 2 data points to the left. So the median doesn't change in this case at all. But the mean, we're going to add 77 into our addition. This data point is so much larger than the others, it's going to have a big impact on the mean. So let's do those calculations and see what we get. The median is 6. The mean is 20.1. The median didn't change in this case at all by changing the size of this data set. As far as the median is concerned, the only thing that we care about is whether points are above or below it. The mean changed from 6.8 to 20.1 because 77 is a very large number to add in to our data points, whereas 10 is pretty similar. Okay, so our mean gets pulled way far away. So the mean is not resistant. Right? It does get strongly affected by extreme data points. So again, look over the upcoming section in the book and be ready for class coming up.